Hello friends, in this video I'd like to solve the following problem from the Baltic Way Mathematical Olympiad Mathematical Competition 1990, problem number 4. We wish to prove that the following double sum, one goes from I equals 1 to n, second one goes from j equals 1 to n of aj over I plus j minus 1 is greater than or equal 0 for any real numbers a1, a2, and so on up to an. So it's a very nice problem. Here is my hint. Hint gives it away, to be honest. Notice that integral from 0 to 1 of t to the power of r dt equals 1 over r plus 1, of course for suitable exponent r. And that should help you. So give this problem a try and I will see you in a minute. Okay, so using my hint, our sum can be written in the following way. Sum from I equals 1 to n, sum from j equals 1 to n, ij, I plus j minus 1. Or maybe I will write the denominator in pink. And now I will do the following trick. My sum stays the same. And now I have ai, aj, and now the pink denominator can be written as an integral from 0 to n of t to the power I plus j minus 2 dt. It is properly given because our exponent of t, since we are summing from 1, 1, it's always a positive number. So this integral does exist. And now let's notice that we have finite sums, so we can freely change the order. No need for any complicated theorem because our sums are finite. And now let's write it in the following way. Integral from 0 to 1. And I wish to write it in like that. T to the power minus 2. Sum going from 1 to n, ai, t to the power of I. Second one goes from j equals 1 to n, aj, t to the power of j. But I wish to write it in pink. ti, tj, dt. And if you look closely, these two sums are really the same. So our result can be written, you know what, just write it here in white. T to the minus second power times sum going from 1 to n, ai, ti squared dt. And notice that our integrand, our function inside our integral, this function is rather non-negative. Non-negative function. So we are integrating a non-negative function, so it's obviously greater than or equal 0. And that closes our proof. Moreover, it's very easy to notice that equality is attained if and only if, in fact, our integrand function being integrated, which is obviously continuous, maybe not obviously, but it is continuous, it's easy to show, it's our 0 is attained if and only if, I believe, every ai should be 0. But you can investigate it yourself. And that closes our problem. Thank you for watching and I will see you next time. Goodbye.